Right. So, first of all, because there's a certain crowd who likes me saying this, like and subscribe my channel, or like the video and subscribe to the channel. There we go. Okay. So, working with graphing sine and cosine functions today. Okay, that is what we're moving into in this unit, is graphing all the different trig functions. Okay, we're going to start today with sine and cosine. All right, but notice, right, we've got all these, right? Sine, cosine, tangent. We're going to graph cotangent. We're going to graph cosecant. We're going to graph secant. Okay, so that's what we're starting off with. But the first two, the kind of the baseline ones, the easiest ones, to be completely honest, are sine and cosine. Okay, now that being said, all of these words right here are going to have to deal with all of them. Okay, so for example, you're going to have a period, amplitude, phase shift for sine, cosine, tangent for each of these, right? And then your transformations, these are your transformations, and how they affect the original parent function. But we're going to graph the parent function for sine, the parent function for cosine. We're going to go over these words, and then we're going to go over some examples. That's what we're doing in the video. Okay, so the first one is the period. Okay, so the period, all right, is the length of one cycle of the graph, and we'll kind of talk about what these each look like. But let's just go ahead and write them down for now. Okay, so this is your b value. Okay, now I'm going to go ahead and write a star because the b value, it's not quite your b value, but we'll talk about the relationship between it. Your b determines your period. Okay, so the length. This is the length of one cycle of the graph. Okay, length of one cycle of the graph, and you will see what a cycle represents when we actually look at the parent function. Okay, the amplitude. Okay, this is represented by a. Now, there's no tricks or anything here. A is your amplitude. Okay, what this represents is this is half the distance between the min and max and max y values. Okay, and we will see that in a sec. And then the phase shift. Okay, now the phase shift is almost exactly what it sounds like. It's a shift essentially from left to right. Okay, this is represented by c. So this is the distance from the y-axis from the y-axis to the start of one period. Okay, cool. Let's go ahead and dig deeper into this. Okay, so A, that's your A value, right, your amplitude. This is going to represent, again, your amplitude. Okay, and what it represents is this is a vertical dilation or vertical reflection. Okay, similar to your A value that you've been working with all year, right? So that one does correspond to the same as what we've been, normal transformations that we've been using all year. Okay, B. So this is the funky one. Okay, but this is your horizontal dilation. It's technically what it is. But let's just go ahead and use the word. So the period. Okay, this is your period. Okay, so use B. Here's how this works. So this is using B to calculate the new period. Okay, of the function. All right, now here's what we're going to work with. So the new period, okay, we're going to go ahead and write this as NP. Okay, the new period is calculated as follows. So the NP, the new period, you take your original period, okay, and you're going to divide by B to get your new period. Now, sometimes, okay, and let's just make like a box or something, like a circle, so we can separate it. Okay. Sometimes your period is going to be a certain value. For example, for sine and cosine, it's going to be 2 pi. Okay, and then for others, it's going to be different. So just for now, understand that your original period does change for each of these, and we'll go over what your period is for each one. Okay, phase shift, C. This is horizontal. Let's go ahead and say this is horizontal. Okay, and in the beginning, this is essentially the beginning of that first period. Okay, the beginning of the first period. And then D, notice D isn't on here, that's okay. D is very simple. Okay, this is a vertical shift. Okay, and that works exactly how we've done before. Okay, the vertical shift. Okay, so with all that information, we're going to respond back. We'll come back to this, but those are the pieces. Now, there's one thing I want to add. Okay, and that is the end point of the first period. Okay, so essentially, if you take your C and your NP, okay, so C plus your new period equals the end point of the first period. Okay, now that's a lot of vocab that we haven't actually seen, and truly to get a picture of what all that is. So let's go ahead and jump in, starting with sine. Okay, so here's sine. And we're going to refer back to this, so make sure you keep that. All right, so here's sine. Okay, let's go ahead and start with the table. Okay, let's go ahead and start with the table, and let's actually go ahead and use our unit circle for this, just to get a good, solid visual. All right, found my unit circle. So let's get our values, right? These are our angles, right? Theta. These are our different angles. Okay, and we are finding what sine of theta is at those angles. So sine of theta, right, on my unit circle, that's my y value. So let's look at my y value at 0, right? Just to confirm, right? We should start to know this, but maybe we don't quite have it, and that's okay right now. Especially when we're developing our graphs, because the graphs are the kind of the second part of this. Okay, anyways, my y value here, okay, at 0, my y value is 0. Okay, so 0, 0 is going to be our first point for sine. Okay. Go ahead and just double check with this. Okay. So 0, 0, that's going to be a point on my graph. Okay, pi over 2. At pi over 2, my y value is 1. Okay, so here we have 1. So at pi over 2, it's a little bit hard to see there, but we do have a point. Okay, and then that's pi over 2. Just clearing that up. I know it's a little bit hard to see. Maybe let's zoom in a little bit so we can get a better view. Okay, then we've got pi. Okay, and at pi, my y value is back to 0. Okay, so we've got a point here. Now, 3 pi over 2, and let's write it. And then we're at 3 pi over 2, so that is, pi over 2, 2 pi over 2, 3 pi over 2, that's down here, so -1 is your point. And then back to 2 pi, which is essentially the same as this. There it is. Okay, so 0, 1, 0, -1, 2 pi. Okay, so that is a period. Okay, so that word that I've been using before, the period, right, that is what it is. And essentially you get this nice little curve. Okay, it should look something like a semicircle, and then here. Okay, that represents one period. Okay, and let's go ahead and write that. Okay, and it's a length of 2 pi. So your original period, okay, for sine is going to be 2 pi. So that's your original period. Okay, original period as we were referring to in this. So if you have a new b value, you're going to take your original period, which is 2 pi, you're going to divide by b to get your new period. Cool? All right. And then the amplitude, okay, the amplitude, that word amplitude is half the distance between your min and max y values, where your max is 1, your min is -1. Okay, so the difference between those is 2. Your amplitude is these lengths right here. That A and that A. Okay, so it's kind of the distance between the halfway point, right, where you've got like that spot that it repeats, right, 0, 0, 0. The distance between that 0 all the way up to the top is your amplitude. Okay, and that's the parent function for sine. Okay, there's not a whole lot more to break down. Okay, but one thing that I do want to mention is that this repeats. Okay, think about it, right? You're going in a circle, right? If you were to continue this pattern here, you're going to add, right, each time from here to here, from here to here, here to here, we're adding pi over 2. So if we were to add 2 pi plus pi over 2, we're going to continue that pattern. So it actually really is best to go ahead and write arrows, right? Because that pattern continues. And now, I know sometimes it's a little bit weird where we have like the arrows just continue down, but just understand that this continues, right? Like this is going to go here, and then it's just going to continue forever. Okay, the sine, it's just up and down, up and down, up and down, up and down, continuing both ways forever. Okay, and I will try to get a visual of that. I'll take a picture. I'll make a note of just trying to show you with those waves. Okay, so show waves. Okay, all right. So that's sine. Let's go ahead and do cosine. Let me find the paper. Lots of papers for this one. Here it is. Come on now. It's on the back. Oh, it's on the back. Okay. Cosine. All right. Now, the difference between sine and cosine, you'll see it, okay? But they're very similar, okay? They continue on in both directions. It's a wave. One is just shifted over, okay? So here we go. Let's go ahead and get my values, okay? Cosine of 0. Well, notice it starts off at 1. Okay, so it starts off at 1. Cosine of pi over 2. I'm looking at my unit circle here. Here it is. Pi over 2. Cosine, there's that value. Okay, pi, that is going to go to -1. And then 3 pi over 2, that's back to 0. And then 2 pi, that's up here. Okay, so that 2 pi there, back to 1. Let's go ahead and graph this one. So 0, 0, comma 1. Right, this is your x, y values for this. Okay, we're using the angle as our x coordinate, right? But then we're using the cosine of theta as our y. Okay, so pi over 2, 0. Pi over pi, right? -1. So down here. Okay, and then 3 pi over 2, back to 0, and then 2 pi back up to 1. So this one is going to look like this. Right there. Okay, and again, it continues, right? So, you know, it's going to hit that and then continue, and over here, hit that and continue. But we just like to graph one period, okay? We just like to graph one period just to show, you know, because it repeats. There's no point to just continue, right? You would be literally writing forever if you were to graph the entire thing. Okay, so that's your cosine. The period here, okay, similar setup, right? Where it's still from 0 to pi. Okay, so that right there is one period. Okay, length of 2 pi. Okay, 2 pi is your original period. your amplitude. Amplitude doesn't change, right? So your amplitude, probably the best place to put it would be here. That's A. That's A. Okay? So either way, both of those are your amplitude. You can look at it right here. That's one. That's another spot where your amplitude is located. So those are the graphs of sine and cosine. Okay? Now the transformations, okay, and the graphing of those transformations is a little bit different than our normal transformations. Okay? So we will see how that interacts and everything like that, but there's a couple tricks to help us. All right? So it won't be too bad. Okay? We're gonna work through it, but you do need to know the vocab, right? You got to know the vocab because you'll be hearing me use that vocab in and out constantly. Okay, but let's go ahead and start with some transformations. Okay, so this first one. Okay, now what's nice about this is in our notes we will, we'll label each point. Okay, so we're gonna talk about each different thing for our graphs. Okay, so let's talk about this one right here. Y equals 2 times sine of x minus pi. Now, keep in mind, your parent function is the sine, right? So it's the sine of x graph. So we're starting with, I gotta keep these handy. Okay, sine is this one. So we're taking this period, right, that repeating wave, and then we're going to transform it, right? You might have different values here. It might be shifted up. Your amplitude might be different. It might repeat more frequently. Different things like that. That's part of the changes that happen with sine. Okay, so let's go ahead and start with it. All right, the phase shift / beginning point. All right, which is your C value. So your C value, in order to kind of talk about where these are each located, this is actually a really important piece that I didn't go over. Okay, but this right here. All right, what this part is this is just showing us where our A values are located, where the B value is located, where the C value is located, where D is. Right? So this right here, let's just talk about each piece we have. Okay, we have an A, right? We have a new A value. We have an A value of 2. Okay, we have a C value, right? So a C value of pi, and then we don't have a D value, right? It's just adding 0, and then we don't have a different period. Okay. All right, but the phase shift beginning point, C. Okay, so we're actually going to begin at pi. Now, one way to kind of compare this, right, is it's essentially your horizontal shift. If you want to write that in here, that's good practice, right? It kind of compares to our horizontal shift like we've been doing with our transformations, right? Since it's a minus a value, we're going to shift the function over to the right. Okay, that's just something to keep in mind when we actually start graphing it. New period. Okay, my B value, like it's technically 1, right? So my period just stays the same. It's just 2 pi. So if you really wanted to see that, right, the new period is the original period with the original period of pi. Original period of sine is 2 pi. So 2 pi divided by 1. Your new period is just 2 pi. Okay, the end point. C plus the 2 plus the period. Okay, your C value plus the period. So pi plus 2 pi. So let's talk about this particular one. It starts at pi, ends at 3 pi. Okay, starts at pi, ends at 3 pi. Okay, your amplitude. Amplitude is 2. Okay, notice it's the absolute value of A. Right? Because if it was a negative, the whole thing's going to flip over the x-axis. Something to keep in mind. So your minimum, okay? Your minimum, if your amplitude is 2, well, let's look at our original, okay? For sine, your minimum was -1. Now, it's going to be here, right? We're multiplying by 2, so it's going to be -2 as your minimum. Your maximum, very similar, 2. And is there a vertical shift? No, there's not, right? We could be adding 0 out here, so it's technically 0. Okay, now, here's how I do this every single time. This is exactly how I'm going to start it, okay? When you have all these pieces, okay, I'm just going to do something like this, where I have an end and a beginning, and then I'm going to put something in the middle, Okay, so I've got an end, beginning, I put something in the middle, and then I get that point and that point, right? And now what this represents, look at my graph, right? Each of these has 5 different points, right? 1, 2, 3, 4, 5. And then it just starts repeating over and over and over. So this represents the end, this is the beginning, this is the middle, and this, the way I kind of think about these is this is like the middle of the middle, right? Or this is the, middle of the middle here. So 5 evenly spread out points. That's the first place to start. Okay? And then you're just going to label what each of these x values is, right? These are essentially your x values for our function. We'll get the y values later. Okay, let's just plot. Let's just put my x values first, and then we'll get where everything is for your y. Okay, so because of the phase shift, we are now beginning at pi. So I'm going to label that as pi. Earlier, right, your sine originally was starting at 0, ended at 2 pi. Okay, but this one starts at pi because of that phase shift there. So it starts at pi, ends at 3 pi. Okay, so ends at 3 pi. Again, start, beginning. All right, now, in order to get these points in the middle, what they are, right? Well, this is the middle of this. Okay, so this entire length is 2 pi. Okay, this entire length is 2 pi. So halfway between pi and 3 pi is just going to be 2 pi here, right? And now, one way to think about that is this length is 2 pi. So half of it is pi. So I'm adding pi to pi, and you get 2 pi there. Now, from here, okay, pi and 2 pi. Well, what is halfway between that? Okay, some people might think about that as 1.5 pi in between pi and 2 pi. All right, and that's okay. All right, if you really wanted to put 1.5 pi, I'm not necessarily opposed to that, but let's practice the fractions. So this is 3 pi over 2 is that location. Over here, okay, this is 2.5 pi. If you really want to think about it, not necessarily opposed to it, but this is 5 pi over 2, okay? Something like that. Now, on this one, think about what we're adding each time. So we're adding essentially, we got pi to 2 pi, that's adding pi. So we're adding half a pi each time. So if you really wanted, you could write these in here. I'm not particularly a fan of that necessarily. We're just trying to get a sketch of these graphs, right? But if you wanted, you could put, pi over 2 and then 0, okay? But from here, I'm going to do a little line like that. My point being, I'm not particularly worried about these. If you just start from pi to 3 pi, we're good, okay? And then you just want to make sure you write your y-axis. So just kind of scoot it over and then put a line. I don't care if you put these points. Cool. On this one, okay, we've got an amplitude, right? So we've taken care of the phase shift. We know I have a point here, 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 and here. So that takes care of my phase shift part of this. Now we've got to be concerned about the amplitude, okay? Well, if we look at my original, right, it starts here, so it's actually going to start, I'm going to have this point, and this point already. The reason why this doesn't change, right, is 0 is your y value. You're multiplying it by 2, so it still remains 0. Okay, so 0 here, 0 is your y value here. Again, comparing this, right, 0, 0, 0, 0, and then 0, 0. So that's this. We've taken care of that. Okay. Again, it's because we have a y value of 0, but then we're multiplying it by 2, so it remains 0. With these in-between values, right, this is where my amplitudes are located, right? We've got 1 originally, but we're multiplying it by 2. Okay, so we're going to go up, this is 1, this is 2, 1, 2, and then over here, 1, these are negative, right? Negative 1, negative 2. Okay, so we're just going to get a sketch, and there it is. There's a point, and here, there's a point. This is my graph of this function. Okay, and then you can put the arrows to signify that it continues with that wave forever. Okay, so that's our first one of writing a transformed sine function. Okay, now a few things. You're always going to have 5 points. Okay, that's every single time with sine or cosine. you're going to have 5 points graphed on your, you're going to have 5 significant points, right? And then again, just remember that it continues forever, okay? But notice, in order to get those 5 points, you start with your starting point, right, which is your phase shift, right? That's the start of a period, and then the end, right? And you got to get that length of the period, right? B represents, helps you determine the length of the period, right? The distance, right, from the start to the beginning. Once you have that distance from the start to the end, and then you just add it, right? You take that new phase shift, and then you add whatever your period is, and you get the end, okay? And then you just get the halfway point here, right? Halfway point here, and then you find the halfway point between these to get this, and the halfway point between these to get this, and then you essentially just kind of fill it in. You just put your points. Like if it's sine, you're going to have 0, 0, 0, okay? Unless you were to shift it up or something like that, and we'll get there. We'll see what that looks like. And then you're going to apply your amplitude, and then if you have a reflection, you use the reflection. Okay, but let's do some more examples. Okay, negative sine of 1/2 x minus 3. Okay, so cool. This one's a little bit different. Okay, this one's a little bit different in the sense that, well, we'll see. Okay, so what we have here is we have a couple different things. Okay, we've got that. Okay, we're gonna have to take care of that negative, right? That's gonna be a vertical reflection. Okay. We've got this, which is a B value, okay? So that's going to mean that my period is going to change. And then we've got a D value here, okay? Notice that it's not in parentheses, right? So it's you know, sine of 1/2 x, and then after this is your shift down, okay? So phase shift beginning point, okay? C value doesn't change here, okay? It's 0. Okay, we have a D value, not a C value. Okay, and again, just to show you where that's located, right? So here it is, A sine B. If we had parentheses, we would have a C, but we don't have those parentheses. So really, it's that outside of the parentheses here is what that value is. Okay, the new period. Okay, so the new period. Remember, this is 2 pi. I'm doing 2 pi because that's my original, but then divided by 1/2, because that's what I have here. Okay, so 2 pi divided by 1/2. This is going to end up being 4 pi. Now, one way to think about this, you could do 2 pi divided by 1/2. Remember, that's the same thing as 2 pi times 2 over 1, right? You're flipping it, so this ends up being 4 pi. Okay, we got to remember that my new period here is 4 pi. So it's C plus the period. Okay, so my C value is 0. The endpoint, so it's C, or the endpoint here is C, so 0, plus the period, which is 4 pi, so it ends up just being all 4 pi. Let's just go ahead and start right there. That means I've got 0 to 4 pi, okay? And I've got the middle, and then the middles of the middle. All right, so 0 to 4 pi, halfway is 2 pi, okay? Here, 0 to 2 pi, halfway is pi. 2 pi to 4 pi, halfway, 3 pi. Okay? That's what we just determined right there. Okay? Amplitude. Does the amplitude change? Well, no, technically the amplitude doesn't change, but we do have a vertical reflection. So we want to make sure we remember that. Okay? Because so the distance doesn't change, right? But it does change in the fact that we flip it across that x-axis. So the minimum is still going to be, well, we got to be careful because we have a shift, right? The D value here is -3, so we're shifting down. Okay, so my minimum was previously, for sine, my minimum was previously -1, right? But now it's going to be shifted down, and so it's going to be -4, okay? It's going to be -4, and then your maximum will be, let's see, so we got to reflect it first. So we're reflecting it first, right? So we're here, reflection, okay? And then we are shifting it down by 3, right? So yeah, -4, okay? So it was, but then the maximum was 1, right? And then we're shifting that down by 3. So then the maximum is going to be, it was at 1 minus 3, so negative 2, right? It's still going to be 2 apart. Notice it's still going to be 2 apart, which makes sense because your amplitude is 1, and your distance between your minimum and maximum should be double that. Okay, so we have all the pieces. Now we just got to graph it, okay? At 0, okay? Notice everything is shifted down, so you're going to have to create like this new, like weird, like half, like middle line. What I mean by the middle line is like your x-axis, right? Like this here is all going to be shifted down, okay? So let's just start all the way down at that negative 3. So I'm going to go ahead and write this line right here. Let's start at that negative 3. So you draw your y, okay? We've got negative 1, negative 2, negative 3, and then we're going to have that negative 4. We're going to bleed down here for a little while. Okay, so that midway point, okay, that midway, that like that, I don't know, I like to think about that as like a kind of an anchor, right? So like we're taking this line and we're shifting it down 3, and then everything else kind of changes from there, okay? So we've got this negative 3. That's going to be a 0 value, right? And let's get the rest of my 0 values. Okay, the 2 pi, and then here, right? And what I mean by that is these. That's these points in here. Okay, everything else does change. Okay, everything else changes here. So we've got, let's see. So since it's shifted down, or sorry, reflected, right? Reflected across that axis. Well, now it's going to be here. Okay, and then from that baseline of negative 3, there it is. Okay, so we've got this and here, and it does continue on forever. Okay, so lots of different stuff going on here. Okay, this changed our x values, right? Normally it was just from 0 to pi was 1 period, but now my whole period is the length of 4 pi. We had the shift down. That changed my little baseline in here. Okay? And then we had the vertical reflection, which changed these, right? Normally, it would be where my finger is and where my pencil is, but now it's here, like that. Excuse me. Okay. That's our second one with sine. Let's do cosine. All right? Let's do a new one with cosine. Lots of different stuff going on here. Okay, I've got the 3, I've got the 2 here, so we got my A, B value. Okay, this is going to be a C value. We got to be careful with that. Plus, this is going to be a D value. So lots of stuff going on here. But we're going to start at the same spot each time. Start with the phase shift. Okay, now notice your C value, right? Your C value is going to be backwards. Okay, and that is because in here, right, the form is pi minus c. Okay, so we have a x plus pi over 2, right? It's just like that backwards h value is what we've been working with your normal transformations. Okay, so this is actually going to be a negative pi over 2. And then we've got a b value of 2. Okay, so the b is 2. I don't like the way I did something up here, but that's okay. The b value is 2. Okay, but the new period, right, and just to kind of backtrack a little bit, up here your b value was 1/2, and then really what this was calculating the new period. So b value of 1/2, but new period of this, okay? So that's what we're doing here. B value of 2, new period, right? It starts with 2 pi, right? Because your period in the normal parent function is 2 pi, and we're dividing it by 2. So it's going to go from 0 to pi. Well, not 0 to pi, but it's going to be a length of pi. Okay? So we have the start point. Let's get the end point. Okay? We now know the length of the period is pi. Okay? But it's starting at negative pi over 2. So that's going to be the tricky part here. So it's negative pi over 2. For your end point, now we have the beginning point. Let's get the end point. So c, which is this, negative pi over 2, we're adding pi. So it's just going to be pi over 2. Okay? I have my start and my end now, so let's just go ahead and do that. Starting value, negative pi over 2. End value, pi over 2. Okay? Good so far. Let's go ahead and get these other three. Negative pi over 2 to pi over 2. It's a length of pi, right? But notice, we got some like symmetry here, which is good. Okay, symmetry is good. It makes our lives a little bit easier with determining these values. So the halfway point between these two is going to be 0. Okay, negative pi over 2 to pi to 0. Halfway point between these is going to be negative pi over 4. Okay, and then here is going to be pi over 4. So we've got those 5 values. Okay, we've got the 5 values. Cool. Amplitude, going to be 3 here. Okay, so instead of, we're working with cosine, so here's your cosine. Instead of an amplitude of 1, this is going to be stretched 3. Same here, and then same here, right? And actually, amplitude there as well, just so you can see all of them. Okay, let's see, the minimum. Okay, let's do the vertical shift first. I don't know why I keep wanting to jump to the minimum. Vertical shift first, so down 2, right? So my previous, this is going to be a little bit hard to find the minimum and the maximum because we got to do a little bit of thinking here. So the amplitude, right, is going to be that 3, right? So it was up 1, but now it's up 3, okay? And so let's start with the minimum. Okay, so negative 3, right? But then it shifted down 2. So it was negative 1, but we multiplied by 3 for your amplitude, and then shifted down 2. So your minimum is going to be negative 5. Your maximum, okay? Your maximum is going to be, let's see, we've multiplied by 3, okay? But then shifted down 2, so it's going to be 1. Now, to double check, right, is that the amplitude, right, is 3, so the difference between your minimum and maximum should be 6, and that is the case here. Okay, and then your baseline, remember your kind of baseline is going to be that vertical shift there. Okay, so here we go. This is my y-axis, right, 0. Okay, got our x-axis. Okay, we're going to be working with baseline. Okay, I like to think about it as that baseline when we have a vertical shift. So let's just be more specific. That's your 0. Okay, that's your negative 1. That's your negative 2. Baseline is here. Okay, and actually we're going to need to make it a little bit smaller. Negative 1, negative 2, because we got to get all the way down to that minimum of 5. Okay, negative 3. Baseline is at that negative 2, so we're going to go 3 from that. So 1, 2, 3. Okay, and then that up of 1. Okay, baseline. Let's draw that baseline. Okay, it's nice to do that. It's good practice, right? You're going to be working around those values there. And just to show you, right, your baseline for that original is going to be somewhere like this. Okay? All right, so let's see. The change, right, that's taken care of. This is taken care of. The shift down is taken care of. We just got to work with that amplitude of 3. So this one, right, that first value, typically you're 1. But because of the amplitude, now it's that 3. So that's going to start off up here. At the negative pi, right, we're going down to that baseline. So there it is. Let's compare it to this. Right? So amplitude of 3, down to the baseline, back down 3. So 1, 2, 3, here it is. And then back to the baseline. And then up, back one more time. So here is your graph for that one. Okay, there it is. okay? And it is a lot, right? But each time getting those 5 values is the biggest part, and then getting your baseline, and then from there, applying your amplitude is essentially what it is. And the beginning values all have to deal with your phase shift and how long your period is going to be. Okay, let's do one more, at least. And if I kind of feel like, we'll see what happens. I don't know. Okay, let's do another cosine. So here we go with 4, and I like to circle all the different pieces we have. Okay, so all 4 different values for this particular one. All right, phase shift, that's always what you're going to start with, the beginning point. So this is minus pi. Remember, that means your starting point is at pi. So this one is, your C value is equal to pi. Okay, and again, don't get confused with the whole subtracting and adding thing. Okay, right, we are taking, it's x, or it could be theta, but minus that pi, right? So C is pi. C is pi. Okay, back at it. So here we go. New period. Okay, the length here, right? I have a B value. That's a B, right? Is A, B, C, D. Okay, since we have a B value, okay, I'm going to go ahead and write your B value is 3. But your new period, that means it's 2 pi over 3. All right, now that's going to cause some issues. Okay, I'm going to be, just to be completely honest. Okay, that's a little bit of a funky one. It's very nice when you have like 2s and 4s because things split evenly. That 3 is going to cause a little bit of a weird issue, but it's mostly just getting the numbers on those 5 values. We'll see it when we get there. Okay, the end point, that's your C, okay, plus this new period, right? Just so we know, C plus the new period. So your C plus your new period here, a little bit weird, okay? But let's convert it to thirds. So pi, right? This is 3 pi over 3, right? So 3 pi over 3, but then plus 2 pi over 3. So your end point is going to be 5 pi over 3. Okay? Cool. Let's see. Starting at pi, new period, okay? All that. Double checking. Okay. So it's going from 3 pi over 3 to 5 pi over 3. Okay? Same thing with your 5 values here, right? Beginning point is pi. End point, 5 pi over 3. Now, here's a trick, okay? If I were you in this situation, I would just write this as 3 pi over 3. Sorry, 3 pi over 3. Okay? Because once you have that, then you don't have to convert everything so much, right? So it's too hard to think about what the halfway point is when it's just pi. But if it's 3 pi over 3, now you can pretty easily find the halfway point. Well, it's 3 pi over 3 compared to 5 pi over 3, right? So what's halfway between 3 and 5? 4. So it's going to be 4 pi over 3. All right, so you keep those thirds in the whole time. Okay, and then here and here, these are a little bit funky, but that's okay. 3 pi over 3, halfway between with 4 pi over 3. One way to kind of think about this is it's 3.5 pi over 3. But 3.5 pi over, it's not really kosher or whatever to kind of write it that way, right? It's grammatically incorrect. 3.5 pi over 3. So that's going to actually convert to 7 pi over 6. So that's what we're going to write here. Okay? Same with this. It's 4.5 pi over 3. Okay? But that doesn't really... 4.5 pi over 3, that's just a weird one, right? It doesn't really make sense there. So it's actually going to be 9 pi over 6. But then even then, that actually converts to... 3 pi over 2. Okay, so if you wanted to write this as 9 pi over 6 just to keep the 6, I'm cool with that. But technically, it's 3 pi over 2. Okay, reduced all the way down. So that's a weird one where it even reduces further with this. But again, if you wrote 4.5 over 3, I'm cool with that. I'm also cool with this. These two are related, and then these two are related. So you have your different x values now, and so you're good to go, right? You just need to get that baseline, and then you need to find your amplitude. And then we just keep that same shape that we were working with. Maybe your amplitude changes, or that baseline, but that's it. Baseline here is going to be 1. Okay, so let's get our amplitude first. The amplitude is 2, okay, but keep in mind it's a vertical reflection. So you got to be careful here. Okay, you got to be careful with that vertical reflection. Okay, but the vertical shift, that's going to be up 1. So let's just go ahead and write our baseline now. Let's just okay, there's our 0. We're going to be up 1. Let's see, and we got an amplitude of 2. So up 1, this is our baseline. We're going to use 2, and we're going to use 3, right? Amplitude, right? Baseline, amplitude, okay? And then, 1, and then here we go. All right, so baseline, up 2 for that amplitude, baseline, down 2 for the amplitude. So finding our minimum now, minimum -1, maximum 3. That's another way to do it, kind of with the visual, right? Writing that baseline is actually a really key aspect, right? Where you find that baseline, and then you apply your amplitudes, right? Up 2, down 2, okay? Let's get those points, okay? Because we now have all the pieces, all right? We're not worried about 0 or anything, but we have to have a point here, okay? We can't forget about the vertical reflection, okay? So on this first one, right, on the original, it was up 1. We're applying that amplitude of 2, but then it's a reflection. So it's going down here. So there's my first point. Okay, and we'll just remember that that's my first one. Okay, and then for cosine, back down to the baseline. Nope, that's not my baseline. Got to remember your baseline is here. Okay, and then up to the top part of the amplitude, and then down back to the baseline, right? Amplitude, baseline, back down, back to the baseline, and then up again. So it's going to be here. Okay, and then your curve is going to look like this. Okay, there, and there. It continues forever like that. And let's do one more. I know this is long, but just maybe if you've got it, you're good to go. You can move on, but I'm going to do one more. Okay, so here we go. Different pieces on this one. Only 2 pieces. Okay, so it could be worse. Phase shift beginning point. Okay, that's going to be your C. Okay, your C value is negative pi over 3. It's a negative because this is adding. The new period. Period doesn't change. I don't have anything right here. So it's just going to be 2 pi. Technically a B value of 1, but new period of 2 pi. The end point. Okay. Again, it's funky here, right? Not the nicest and neatest, but we've got a C value of negative pi over 3. We're adding 2 pi here. So I want to convert this to thirds. Okay, so 6 pi over 3. Okay, now my end point is just my C plus my new period. Okay, so it's negative pi over 3, but plus 6 pi over 3, so this is going to end up being 5 pi over 3. Let's go ahead and do it. Start, end. Okay, these are 6 apart, right? 6 pi over 3 apart. So halfway, right? We're just going to be adding 3 pi over 3. So that is going to be 2 pi over 3 here. Pi over 3, right? Adding 3 pi over 3. Adding 3 pi over 3. Cool. Here. Okay. In between, it's adding 3 pi over 3. So this is like adding 1.5 pi over 3. So we have negative 1 pi over 3. Adding 1.5 pi over 3, this is like 0.5 pi over 3. But that's going to go ahead and convert to pi over 6. Okay? All right, double it. Okay, so this is pi over 6. Okay? One way you could maybe help with this, or if you need help with this, is convert everything to sixths. Okay? There's nothing wrong with that. This is negative 2 pi over 6. Okay? This is 4 pi over 6. So in between, it would be 6 pi over 6, so you'd be adding 3 pi over 6, and that's where you get this. Okay? Lots of different ways to crack that, but do what works best for you with the fractions. Okay? 2 to 5, so that's adding 3, so adding 1.5 pi over 3. Okay, so that's this part is going to be like 3.5 over 3, but that converts to 7 pi over 3, so that's what I'm going to, sorry, 7 pi over 6, 7 pi over 6. So there is that. You've got your 0 is in between here, okay? I don't really care about where you put the 0. There it is, boom. I guess it's not really halfway in between, but that's okay. We're sketching here, right? This is not a perfect drawing by any means. Okay, your amplitude is 3. Notice your baseline doesn't change here. There's no shift, so your baseline is 0. Okay, but we are back to sine. Okay, so for a little while we were doing cosine there, but we are back to sine. So there is your parent function. Okay, it's very nice when you have a normal baseline, right? Because then you don't have to shift things up or anything like that. So your amplitude, you use your baseline, which is your vertical shift, and you're going to go up 3, or sorry, down 3, I guess, for your minimum, and then your maximum up 3. Okay, so since it's sine, okay, it's starting at that 0, 0. Okay, so 0, 0, and 0. Okay, and then you're going to have to go up 3 here. So 1, 2, 3. There is your top one corresponding to this. And then your bottom one, you've got negative 1 here, negative 2 here, negative 3 here. So there it is. Oops. Right here. Okay. So up here, back down, here, here. Okay. That is your graph. Okay. Lots of working pieces. All right. But the biggest thing is you start with your beginning using your C, go to your end using your new period, right? You add that new period to your beginning. You get those 5 points, okay? You find your baseline using that vertical shift. You apply your amplitude, and then be careful when there is a vertical reflection. All right, but that is graphing sine and cosine. Have a great day.